Hello and welcome to Practicalli. Thank you very much for joining me. My name is John Stevenson, and today we're going to continue looking at some of the Codewars challenges that we started last week. So if you missed that, take a look at the video. Essentially, Codewars is like an online gamified website where you can carry out a whole range of challenges at lots of different levels. And they feed you levels, they feed you example challenges, roughly based on your level, trying to push you a little bit further every time. So it's quite a useful way to keep you motivated as you're learning a language. And you can do it in Clojure and many other languages as well. Each challenge lists which language it's actually supported in. Okay, so we're going to do two challenges today. We're going to do print codes and we're going to do split strings. So they're fairly easy, fairly straightforward. There's a few little twists that we'll come across, but hopefully you should be able to follow along. And feel free to ask any questions as we go along in the chat. So as usual, you can find all the Practicalli information on the Practicalli website. So practical.li or practicalli.github.io. And there's all the screencasts. Oops, there we go. And then there's books I'm working on. And if you want to get in touch with me, you can reach out via the Clojure Slack on the Practicalli channel. But I'm also on the usually on the Spacemax channel as well, and beginners and so on. So there's quite a lot of help you can get from me and from the rest of the community in the Clojure Slack. And if you don't have an account, you can sign up using this link as well. It's all self-serving as well, so it's all free. And there's just some ways you can support me as well. Cool. Okay, let's have a look at the challenges that we're going to do. So the first one is printer errors. So this is a factory that prints out labels for boxes, and the printer, and for one-of-a-kind boxes, the printer has to use colors. And for some reason, the only colors that are supported are A to M. And so if there's a color code that's made of strings that are between A and M, then the printer is going to be happy. But if there's going to be like a bar, if it's going to be characters that are outside A to M, so N to Z, then we're going to cause an error. So we need to write a function that will call printer error, which will give a string output, kind of the error rate of the printer as a string. So we're putting out, so we're going to calculate how many errors are in a particular string, and instead of just having that as a number, we're going to output that as a string and put it as a ratio, put it as a fraction rather than a decimal point. So in this string, they're all the characters are between A and M, but in this string, then we've got some characters that somewhere there's 8 characters that are there's some W's in there, which are and some Y's. And so there's, out of the total of 22 characters, there's 8 errors inside that. And so we're printing out that. In Clojure, we could actually do that as a ratio without the string. But I guess this is done for, it's written for most languages. So in terms of the instructions, most languages don't support the ratio type. So we're going to do that as a string anyway. Right, I'm going to switch to my editor. So I'm using Emacs. Oops, there's Maggot. And you can use any Clojure editor you want. You can even do this on the REPL, and of course you can do it inside Codewars itself. So I've already done this exercise, but you can go in and train again, and it will go in and start the challenge from scratch. So this is quite good, like if you want to just start again and try it in a different way. You can go over and over and round again, try it in lots of different ways, and helps you explore different aspects of the language you're working in. And then there's like tests as well, sample tests you can run just by clicking run sample tests. So at the moment when we run sample tests, our code is not going to work, so we're going to get fails. So we need to make that pass. Okay, I'm going to do this in my editor, just because I just find it easier to do this. So there's a bit of instruction. So this is a instructions we went through. This just copied from the website itself. So how are we going to do it? So we've got our example code there, our example tests we can need to generate. And so we need to count the number of error codes in a given string. So we need to find out the total number of codes that are in there, and then calculate the fraction that are incorrect. And then we need to return that as a string. Oops. And so we've got an input. We've got an input of a string of printer codes, and each of those is it's interpreted as a character in the strings. The code is a string, so you got A is a code, B is a code, so that each of the characters in the string are all individual codes. And only A to M are legal, so we need to drop the other half, or at least like find out when there's an N to Z. Then we need to count those as errors and return that. So how could we do this? Well, we're quite lucky that so a string in Clojure is represented as is really a collection, as a sequence of characters anyway. So that's fairly easy to oh, I can't spell. There we go. So it's very easy to convert and use functions from the Clojure core on a string, and we can actually use string as a very basic kind of collection of characters. Sometimes the tricky bit is to get the characters back into a string, as we'll see. So here we've got our example string with for our printer codes, and I'm just putting that into a def. So we can refer to that, and what I could do is create a set of all the legal codes, and so then we can check to see if each of those codes are actually in there. We could use a string for each of the codes, but this isn't going to work so well because we have characters. When we look at the individual characters in a string, there are actually the character type. So they're actually so this slash A is actually a character of A, whereas the double quote around the A is actually the string of A, and they don't actually equal the same thing. So if we need to compare them, we need to use, if we're going to have a lookup table for our legal codes, then we'll need to have them as characters because we're going to look up a character, or we'd have to convert each of our characters back into a string again for this expression to work. So if we have so if we uncomment this, I'm just using the reader macros for these. So the #_ is a reader macro. Just something I'm used to using. It's the same as using the comma, except it works on so comma works on lines, whereas the reader macro works on the entire expression. So if you do we do this over multiple lines, then we're going to get errors. Oops, and my computer does strange things when I change the formatting. Whereas if I do the #_, oops, oh, press the right button, there we go. Then this will comment till the end of the expression. So the matching closing parentheses. So that's commenting out. So basically tells the Clojure reader just to ignore the next expression. So I find that quite useful as a way to comment things out, especially when I'm experimenting and creating a design journal in that way. So I've got, I haven't got my cider running. Let's run that. So I'm just going to run my Clojure REPL. I'm just running that from the editor itself. And now I can evaluate this def. So now I can refer to all the legal characters just by this name, legal color characters. And yes, I'm using the American spelling for this. And so we could do something quite simple to just remove. Oh, I didn't evaluate that. There we go. So we could have this very simple function called printer errors, and it's going to take a string, and then we're going to create a couple of local bindings using this let expression. So we're going to work out the total. So this is going to be a local name that's going to be bound to the result of calling count on our string. So how many characters are in this string? So again, this is count, treating the string as a collection of characters. And then we've got errors as another name, which is going to count. We're counting the total of the illegal characters. So we're first going to remove all the characters from the string, all the legal characters from this string here. And to be able to do that, we're going to just treat the string, we're going to convert the string into a sequence of characters, and then we can remove these characters. So remove is a bit like filter, except filter will keep the things that match, and remove will remove the things that match. So this will remove any of these characters from our big string, and then we count up how many there is, and then we simply just use str to print out a string that combines the errors value divided by the total value, and we get a string. So we should get an evaluation for this. Let's just evaluate this function, and we call this, put that as a comment. There we go. So we get 3 over 56. So there's 56 characters in there, and 3 of those are not legal error code. So we get X, Y, Z at the end. Yes, so that's a fairly easy one to see visually how many there are in there. So we've got confirmation visually that that's working okay. So that seems to work just fine. And if we put that into Codewars, then it would be, yeah, it should pass. However, it's kind of a bit verbose, and we're using a lot of local name bindings, which, if we're doing like massive strings, or we're like doing this over big data, then that does kind of burn up a little bit more compute resources. So there might be an easier way to do this. But let's just go and see if this actually does work. I can't remember if I actually tested this or not. Let's see. Where is my browser? If I remember how to paste in this. Oh, I've got Vi mode on, haven't I? There we go. Oops. Not quite Spacemax. Oh yeah, I think this is the problem I had last time, was just copy pasting into Codewars. There we go. I shall get there eventually. Let's see if this works. Does that work? Control B. There we go. So let's just delete this. Oops. Boom, boom, boom. Okay, so we can run our sample tests, see if it works. Did it work? Oh, it didn't work. Oh, yes, of course, I forgot to copy the other bit of the code in. There we go. So I need this this set of characters. I need that to make my function work. So let's just paste that above. Oops. Boom. That doesn't like working there. Come on. Boom, boom. Try that again. Why? Control paste. Oh, do I need to be in? Yeah, there we go. Need to be in insert mode before Control V actually works. There we go. Right, so I've got legal curry character. So if I run the sample test now, then hopefully it works. There we go, it works. So that's good. So it could run the attempts, and then it runs with a full test suite. See if there are any issues. And then, so it runs a whole bunch of other tests in there as well. Wow, that's quite a lot. And I could submit that as a final, but I think there's ways we can tweak this. I think I did some other solutions in this. Let's see what we did. Yeah, so we've converted it into a sequence of characters using this seq function. I removed the characters. Oh yes, I did a regex version. So rather than having the this legal color characters thing, we could just use regular expression. Save a bit of typing there as well, and also a bit of error conditions as well. If you mistype or if you miss off a character, then that could be a bit unfortunate. Whereas if you use regular expression, we can't just use it as a just as a function itself. But if we use a re-seq with that, we can basically generate a new collection based on the regular expression pattern. So we can see here we're taking our big long string that had all the legal characters except for X, Y, Z at the end, and re-seq has generated this to create a new sequence of characters, or sequence of strings in this case, and it has just kept the ones that are error codes, so just N to Z. So a regular expression, we start with a hash, and then inside the double quotes is the pattern that we actually use for a regular expression. So if you used to do regular expressions in other languages, then you would just put the pattern inside the hash double quotes. And here we're saying we basically want to have any character that's between lowercase n and lowercase z. And this is U is the way that we're referring to our big long string, uber string. So we could then just do count on that. We get the value for that. So that saves us. So we don't need to do the counts on using the legal characters. We don't need to remove them. We can just use re-seq and count the results of that. And so we can update our print error function in here and just use the re-seq instead of the legal color codes. So we don't actually need that lookup table, that lookup set. We just use this, and let's switch back to here. So we can get so we can put in our new function. Let's go into insert and paste. Oops. And then we can get rid of this one, this one, this one, this one. And we don't need our legal custom characters anymore. There we go. And so this should still work. Let's see. Is it going to work? Woo! Yay! So it's running all the sample tests and hopefully running the full set of tests. Excellent. And this feels like we're using more of the Clojure core functions to do things with using a slightly higher abstraction. So that's quite nice. Did I do anything else? I can't remember. Oh yes. Yeah, so this gets rid of like an external dictionary. So we get rid of those legal color values that we don't need. And it's all self-contained as well. So in our other example, our function is not entirely pure because we're pulling in this legal color characters. And if somebody had changed that and wrapped it in an atom, then we have less certainty about what's actually included in that. We would to fix that, we would need to include the argument that was the legal color characters set that we wanted to work with, which could be useful to help work with different printers. If different printers had different color characters that were legal or not legal, then having a second argument that is that's the argument that takes in the set of legal characters, then that makes it more adaptable to different printers. But our API for Codewars is kind of pretty fixed, so we can only call print errors with a single argument. Although we could get it to call itself, we could do a polymorphic function, but then we're still hard coding the characters that we're pulling in that way. Okay. And then did I do anything else? Oh, yes. And so the final improvement we can make, so we've still got these local names that we're binding to, and obviously when we're creating these local names, it's going to add more, it's going to use more memory space. I mean, it's not significant in here, but again, if we're doing this on scale, we might want to get rid of those. And so what we can do is just create a string and take these two functions, these two function calls we created. We can just put them inside here and here, respectively. So we've got this. So what we're doing is just putting the functions that we've got in place inside this string function. So we've got string, and so errors is this function call, and then we divide that. We put a divide character in there, and then we do the count. So this gives us our same result as well. And so now we've got that. So we can put that into Codewars. What is probably the final time for this one? Outstanding. There we go. Go into insert, do copy, paste, Control V. There we go. And let's just. Oops. Did I do that? What did I do? Oh no. Boom, boom. There we go. Oh, there we go. So now this should still run. Hopefully. Oh, there he goes. And it's a little bit less code, but hopefully it's still pretty much readable, because these functions here are fairly small and fairly low complexity. I mean, obviously count S is quite simple. We're just counting the argument that we're getting in, and here we're just creating a new sequence using a regular expression and then counting the results are there. So it kind of makes sense to put them in line. I'll submit that as my final solution. Woohoo! And then we can also have a look at the other ones here. So Pretty much, yeah, everybody's kind of done the same kind of thing. So this is exactly the same as mine, it's just all on one line. And I don't think there's anything else interesting. So you can reduce, okay. This perhaps is a bit over the top for this solution, because we got a reducing function, reducing everything by plus. I guess this is to get over the I don't really know, actually. That's an interesting one. But yeah, there's quite a lot of stuff going on there. And they also, so they're working with characters here, and then iterating, doing a reduce function over characters, using a for, which is also doing iteration. So they're iterating over several things. They're generating a map of the characters from range, I guess this is N to Z, possibly. Yes, I think so. Yeah, and then doing a filter. Okay. So this is good that there's a lot of functions being used here, but sometimes it's very easy to overthink these small solutions as well. But at least this has given you the person who wrote this a chance to explore how to do things in these functions, because sometimes it's not always a simple case as we've done so far. Somebody's using format to format the string there. Interesting, cool. But it gives you a chance to go and browse through all these, and all of these solutions work. It's just that you can also vote on which you think are giving you the best practices. I think the one that we chose gave the best practices as well. Yeah. So there's nothing wrong with any of the other solutions. They're just sometimes you can optimize the code after you've written it to make it a bit more streamlined. And if you write less code, then potentially it's easier to administrate, as long as it's still readable and easily understandable. Okay, so I think that's the solution I went with. Yeah, that's the solution I went with. Cool. There doesn't seem to be any questions about that, so hopefully that was fairly straightforward. Let's have a look at the second one. Oh yes, we're on time. So split strings. Okay, I just did this last night before I went to bed, so I think I've got a decent solution. It's fairly. This is supposed to be harder than the one we've just done. This was, I think this was so print errors was a 7 KYU. So this is a 6 KYU, which is supposedly slightly harder. I actually found this a bit easier, actually. So, but I guess if you know the right functions, then everything's easy. Okay, so let's have a look at this in my. So what do we need to do? So we need to split strings into pairs of 2 characters. And if the string that we've split contains an odd number, then we replace the missing second character with an underscore. So here, if we pass in ABC, then we should get a pair that's AB and a pair that's C. And because C is by itself, then we put an underscore in there as well. And so if you've got an odd number of characters, then the last one's going to have an underscore. If you've got an even number of characters, then they're just going to be the pairs. So this seemed pretty simple when I started last night. So let's have a look. So switch to where are we doing? Boop, boop. I created created a new project for this. So I'm just using the deps.edn projects. So let me just open this. Boom. Boom. So basically all I did was, I ran Clojure on the command line to create a Clojure CLI tools, it's like a Clojure deps project, and I just use this alias, which is new, which is the CLJ new library. Just helps you create new projects, and I'm just created a lib project as well. So I've put instructions in the main README of the GitHub repository for this. So it kind of shows you how to run stuff, and in the READMEs themselves, I'm going to put. Did I put this in there? Oops, I didn't. I will put the instructions on how to create the projects as well. Yes, I will update that today. But essentially, it's just if you've got Clojure CLJ new installed in your deps.edn file, then you can just do this command and it creates a new project for you, and you get a nice project layout like this. It's generating your deps.edn file for you, and also generates a POM if you need one, but I don't really use those myself. And then it's got the source tree with split strings and a matching test tree as well. Cool. There's a question from the audience from the let bindings. Does the compiler inline the let bindings? I think you're still using memory, so you're not getting like the full kind of inlining. There might be some optimization going there, but code that doesn't have let bindings is usually more optimal than code that has let bindings. So I think essentially the answer to your question is no, it doesn't inline the let bindings in the way that you're thinking that it gets rid of them. Although there might be some techniques that I'm not aware of that you can use to do that. If you're running it through Graal and compile it that way, so compile it natively, then maybe there's a lot more techniques it does. Or if you do AOT, it does that as well. So there's another question, oops, where is we going? So the other question is, how do we know what options to pass to a new? So there's lib and there's app. So it's kind of the same basic options if you've used Leiningen. So there's lib if you're just creating a library, and then there's app if you're going to create an application that you want to run on the command line. So it adds in the gen class to the main namespace, and just allows you to run that project from the command line. So this is just like the project types you can get from Leiningen. So there's lib and app built in. There's also a template one for generating your own templates. But then you can also use all of the Leiningen or boot templates that are out there as well. So if you just if you Google for line template, or if you look at any kind of project like Ring, so you can use you could use Composure in here, or Ring, or Figwheel main, and they will generate those templates. The only thing to be aware of is that if it's a template for a Leiningen project, then it's going to generate a Leiningen project, so you would still need to add your own deps.edn file. And if it's a boot project, obviously it's going to generate a boot project for you. So it's not going to convert a Leiningen template into a deps.edn template for you, but it should do most of the work, and it should just be a case of adding a deps.edn file. Yeah, so if you go to reframe, it should tell you how to create a new project with their template, and hopefully by now it's got a deps.edn version for that as well. If not, you could use the Leiningen one and then just add a deps.edn file as well. Let's see. Okay. That seems to be the questions from the audience. Let's have a look at split strings. So we've got, we basically want to call a function with a string as an argument, and split those into like pairs of characters inside the string, and make sure that there's no odd ones left by putting in an underscore. So when it came to splitting things up, I immediately thought of partition, because I've used partition quite a lot, and you tend to use the functions that you use quite a lot. So if I do that, partition will kind of do most of the work for me. So now I've got, it's partitioning, it's converting them into characters. So as we saw before, you can use a string as a collection of characters. So what partition is doing, it's going to take groups of 2 values, so groups of 2 characters in this case, and it's going to create a partition for each, and return that as a sequence of lists in this case. It's a sequence of sequences. So there we go. However, if we do this with oh, you can see that there's the G is missing. Where's the G gone? It's gone. It's missing. So partition will drop anything that doesn't fit into the partition number. So we've got a partition of 2. Then there's an odd number of characters in this string, so it's just going to drop the last one. 1, 2, 3. Oh yeah. And if we did the same thing with 3. So we got a partition of 2 partitions of 3, but because this is 7, we're still losing the G. So this is kind of a lossy version of partition. But luckily we've got partition-all, which will partition everything, including the G. So we've got the G back all by itself. So we could use that and then go back in and add the underscore to the G, so it's not alone. That seems to be fairly straightforward. And then if we go in, but we still need to, in order to do that, we'll need to convert these back into strings, and also for the answer, we'll need these back as strings as well. So the only problem with that is that if you just map string over this, then we're going to get, oops, press the right buttons. Then we get lazy sequences. No! And we get the same thing for this. And even do all doesn't help. And applying a string, that doesn't help. Although we get a slightly different organization of lazy sequences. Then we get here, we're doing that, but it's only done a little bit of that. I'm not even sure what this is doing. I didn't bother looking into it because it was quite late. But that's an interesting way. And then, what did I do? Oh, I tried putting it in a function. That still didn't work. And then I figured out how to do it. So I'm basically mapping apply string over each of them. So I'm applying a string to each of the sequences. And this gives us the result I actually wanted. Yay! It can be a bit frustrating if you get lazy sequences out when you don't, especially when you don't want them. But this doesn't happen all the time. Part of the reason is that so map is lazy, and applying string is going to be lazy as well. So we're getting these lazy sequences. They will only give us the value when we make the expression eager, when we bump into something that's eager. So laziness can be extremely useful when you've got, especially when you've got a large data set. But at some point you need to make the expression eager so you actually get the results that you want. There's probably I'm still trying to think if there's a better way to do this, but it works quite nicely. So basically we're just mapping a function over each of the sequences that we produce. So we're taking this function here and applying string to this, and then we get like a string of CD. And then we do the same thing for this sequence and this sequence and this sequence. And so we get the answer, the shape of the answer that we actually want. And then, so I put that into the solution. And so we're going to map, we're going to check if the count is equal to 1. And then we're going to we're going to basically take that character and add the underscore to it at the end. And if the count isn't 1, then it's going to be 2. So we just return the pair of characters as they are. It's just the string as it is. And so that function is going to map over the results of partitioning our original string by 2, and then putting it back in like a sequence of strings, putting it back into this form. And then we map this function to determine whether any of these should have the underscore added to the end of them. So if we evaluate that and evaluate that, we get the right results. So we've got G at the end, which is got the underscore just to balance it out. Oh, wrong one. There we go. Fairly simple. So hopefully you've followed that okay. But is there anything we could do to tweak that? Yes, there is. Because I was thinking, so this is doing, so I think one of the things it's talking about in the challenge is how to do this the most optimal way. So we're creating a partition of all the characters in there and converting them back into a string, and then we're doing another iteration over that sequence of values, and then adding that string, adding this underscore to any odd strings. But if we step back for a second and think, well, actually, if we do some lateral thinking, if a string is an odd number of characters, we know we're going to add the underscore to the string at the last character at the end. So why don't we do that before we partition? And then we don't need to do another iteration over that. One refinement I did, so rather than doing equals 1, I just did, is it odd? That's a nice replacement, because I think it makes the code a little bit more readable as well. So we're just seeing if we've got an odd number. We would get tripped up a bit if somebody changed this to like partition 3 or 4, if they changed the way that we were doing the partitions. But if we're certain that they're not going to do that, we can use odd instead, just to make it a little just bit easier to read and work out. So we can add, so rather than doing the rather than appending the underscore at the end, we could just do that before. So we could just put if the character, if the string has an odd number of characters, then we can add the underscore at the end. Otherwise, we just return the string as it is. So that's kind of replacement of this. And so what we can do is then, just as this is a bit more simplified, we can just run this over partition. So the results of this, so we're creating here we're creating an even number of strings, either by just returning the string if it's got an even number of characters, or just putting that character at the end. And then we got our solution, which is not quite with the right form, so we still need to put that apply string in there as well. So we just refactored this a little bit around, and we've just, rather than using an inline function, we're using partial instead. So just partially applying string. So string will be applied to each of these sequences when we get the sequence. That's what partial means. It says a wait to evaluate apply string until you get the data that you're actually going to work on. So normally there'd be some we'd need to put in the placeholder in here, but because we're using partial, it's telling apply string to wait for it to fetch all the data it needs to be able to run, and it's getting that from that simplified way of adding of creating an even number of characters. And so if we do this and this, we get our results. So this is the solution I think I want to go for. Yeah, because we've got a partition of 2 of our even number of strings, either by default or forced, and then we're just converting that back into a string in the right form that we're looking for here. Okay, let's go and just double check that that's all still working inside Codewars. Back to Codewars, boom, split string, and so if we go in and do paste, yay! I've mastered the pasting in Vim style. There we go. Get rid of that. There we go. And if we run our sample tests, woo, they work. Oops, sorry. Press the wrong button. There we go. So it's done the sample tests, it's run all the tests. They've all worked, and submit that to final. Drum roll. Way. There we go. So there. Oh, Waffles has done this. Excellent. Oh yeah. There you go. So you can see that there's not a huge amount of stuff in between, because this is more or less the last but one solution I did, and so all I've just done is refactor it a little bit and put the just put the conditional before we partition. So put the conditional around this around the string, and then it means it does mean that we've kind of streamlined it a little bit. So we're applying the string, so we don't actually need, we've still got this map of apply string. So this apply string is essentially the same as partial apply string. Partial is useful if the arguments you're giving to your function are in the right order, but if you need to change the order, then dropping down to an inline function like this allows you to have more flexibility. But in this case, it's just as easy to use a partial, and it's just as a slight refinement. There's not a huge amount of difference in here. I think this would probably be just slightly nicer, but there's not much difference in that. Ooh, there's my other solution. How many solutions have I got? There we go. Cool. I'm going to vote for mine. There we go. Let's just see if there's any other ones that are interesting. Somebody's using a thread macro using mod. So okay, yeah. So they're dividing the count of strings by 2, and if there's no remainder, the remainder is 0, then there's an even number of characters in the string, and so we just return the string. Otherwise, we return the string with the underscore. Then we're partitioning it. So it's kind of using the thread last macro. So the result of this is going to end up as an argument to partition all, and the result of partition all is going to end up as an argument to map partially apply string. I'm not sure if that adds anything to it really. If you've got, if there was more functions, if there's a whole kind of pipeline of functions, then certainly the threading macro does help you look at the code in a more sequential way, so you can kind of see the data flowing through each of the functions a bit more clearly. Sometimes if you've got a big reduce and you've got an accumulator map, you can see what functions are passing through the big map as well. And I think if there's the git practically, not that one. There's the code. Oh, there we go. Clojure through code example, and it's the Hitchhiker's Guide to the Book. Yeah. So here we've got. Let's make that bigger. Wee. Here we've got some book data, which is just slurping in a text file, text of a book, and we're going to take that big string of the book. All the text in the book is one big string. We're going to do a re-sequence of that, again using a regular expression. So it's basically going to split everything at words, but also take care of commas, so apostrophes as well. And then we're going to convert everything to lowercase, and then we're going to remove the common English words, look out the frequencies of each word, sort them by value, and then reverse. And then we'll get the most commonly used word in the book that isn't a common English word. So this is like the, and so on. So all of those are obviously going to be used way more than other words. So we strip those out and then say, well, what's the remaining most common word that's used? So this this thread last macro kind of helps you see the kind of the sequence of events that's happening to the data fairly easily, which is sometimes a bit easier to read, especially if you're like new to Lisp style. If you didn't do Lisp programming before you did Clojure, then this threading macros is sometimes easier to read, because this is the same code as this, which is a more nested approach and more classic way of writing Lisp code. So you've got your re-sequencing the book, and then you're going to take that result and wrap it in, and then we can lowercase all the characters, all the strings in there. We remove the English words and the frequencies, vowels, and we sort by vowel. That should be on the same line, I think. And then reverse. So the threading macro can be quite useful sometimes, but if you've only got one or two, then in our case, then it's probably not adding a whole lot. But some people just get used to using it, and it's fine. Cool. Alrighty, we're about time. If there are any questions, then let me know. If you reach out to me via the Clojure in Slack, or you can email me at john@practical.li. Or you can do the Twitter thing if that's your thing. And yeah, if you have any particular things you would like me to cover, then please let me know. I was trying to think of ideas that will be of interest for everybody. Okay, there doesn't seem to be any more questions, so I'm going to leave it there. Thank you very much for listening, and see you next time. Thank you. Bye-bye. Yeah.